for today is an introduction to memory forensics. Basically, I'll be talking about the ins and outs, kind of overall oops, what forensics is, why it's so important to digital forensics. I'll also be talking about what exactly is volatile memory in regards to memory forensics, and as well as the tools and for stuff like acquisition analysis. Sorry, let me go and pass it to Brad to make a few announcements.
Gotcha. Press the button. Okay. So, just a quick couple announcements. This Friday, we'll be having a collab workshop with the CSS Club. CSS is a computer science club on campus, and we're going to go over some web web application vulnerabilities, and we'll be talking about different vulnerabilities that exist, as well as having a barrage of activities, specifically regarding the OWASP Juice Shop, which is a um, open source application made by OWASP to demonstrate different web app vulnerabilities. So if you're interested in that, hopefully I'll see you there on this Friday from 2 to 4. It'll be different from our normal NCL workshops that we'll have, but hopefully it'll be just as exciting. So other than that, we have a couple more events coming up that you guys could all use the check on the Discord announcements for any further updates. And with that, I'll pass it back to Alex.
Thank you so much, Brad. Okay, so again, I'll be going into why memory forensics is so important, what it could be used for, use cases and scenarios. I'll also be going over the tools of the trade, how do you acquire such data for memory forensics and how to analyze it. And unfortunately, I'm going to have to cut the presentation a bit short. I planned on doing a demonstration of the analysis tool volatility. Unfortunately, it broke on me at the last second. I couldn't get I can get it working. So I'm gonna have to cut it short. But anyway, yeah, I think I'll still go through kind of how it's used. But I'll talk about more about that later on in the presentation. Okay, so what is memory forensics really? It's not too dissimilar to digital forensics. In fact, I'd say it's a subfield of digital forensics. Basically, it's digital forensics is, trying to collect evidence and then build up either a report or investigate an incident or malware attack. And memory forensics plays a big part in digital forensics when it is utilized properly or when it is utilized. Essentially, its goals are to harvest available metadata, including process details, network connections, and other information associated with potential malware. For system processes, which are applications that basically run the system, we can use memory forensics to recover the executable code from memory for further analysis. And we also want to use memory forensics to extract associated data from memories, such as related encryption keys and other data, such as usernames and passwords. Okay. So again, there isn't too much. There aren't digital forensics and memory forensics are but distinctly separate in their own ways, because memory reflects the kind of running state of the system. When you think about digital forensics, you think about capturing images, basically snapshots of disk files like a suspect's hard drive or soft SSD. What memory forensics does is it is a bit more current. It captures the running state, the current state of the system, not just a snapshot of data that has already been written. And so it's also important for malware analysis because some malware don't actually leave a standard pattern that is detectable on the hard disk. Hello. And yeah, it's not, some malware patterns don't write a standard pattern on the hard disk. It's some malware are actually memory resident and they only affect memory. So when you do kind of standard digital forensics, some malware, you're not able to detect it on the hard drive when you do your analysis. And that's where memory forensics can come into play. Memory forensics is also useful for constructing a more detailed report and recent activity. stuff like what the user was seeing at the time of the capture or before. It's basically, it just comes in handy where digital forensics kind of falls short. So what exactly is random access memory? It's a component of the system where it kind of acts like a buffer space for the central processing unit of the computer. Uh, it's essentially a space where it can draw and receive, access, and store data whenever it needs to be utilized by the CPU. Whereas regular storage, it's for writing more persistent data that can be used for things like files, user files, and stuff like that. What makes RAM different from regular storage is that it is not organized by a file system per se. Random access memory is organized by addresses, and they are sort of dynamically allocated where the CPU needs to send or receive data where it sees fit. And one more thing, it needs to be volatile. And what volatility means in regards to memory is that it's in a constant state of change, and it isn't going to be persistent at all times. It's always going to change. That's why also it's called sometimes RAM is also referred to as volatile data. Next slide. Okay, so how can we exactly acquire guess memory images of RAM? In other terms, captures of memory are called memory dumps. They usually come in either a raw format or a page file or hibernation in the case of Windows machines. And acquisition requires privileged access because you are accessing a higher level component of the computer. It's going to require some it's going to require some privileged system calls, aka functions, to draw and read memory. While you are acquiring data from memory, you want to avoid changing the system state during dump, aka basically you want to avoid touching the computer while you're changing the dump because anything that any action that is performed on the computer during this time can affect the state of the memory dump. And that might change some evidence based on what you're looking for. So you want to avoid doing that. Okay, so what are some tools that we can use to do memory forensics? Basically, there are a large array of memory dump utilities. Just three that I can mention here are Dumpit, which was an open source forensics tool. I believe it is no longer being developed actively and was acquired by Magnet Forensics. But in the past, it was a big. It was a tool that was used widely for memory acquisition. Belkasoft RAM Capture and FTK Imager. Um, Basically, some of the more big name forensics companies do have RAM capture, their own proprietary RAM capture software. However, for on the analysis side, there are a similar amount of tools available, but the most notable are volatility. The most notable actually is volatility because it is, for other reasons we'll talk about later in the next slide, has been developed for quite a long time and has been used across the field by professionals and casual use and whatnot. One other tool to mention is memproc-fs. This is a tool that actually allows you to mount a memory dump as a file system. So you can mount a memory dump onto your actual computer file system and browse it like you would a regular file system. Okay, next slide. So volatility is the tool of the choice here when it comes to memory analysis because it is so modular. It is an open source tool developed actively being developed by the community. It is written in Python and it is a command line framework. Notice how I don't mention that it's just a tool or one utility because it's very modular. It has support for a wide array of plugins. It works on Windows, Mac, and Linux machines, as well as many others that I could mention. Yeah, Ncase. Ncase, I'd say just for digital forensics work, not necessarily memory forensics work. Ncase is a pretty good analysis. When did it cut off? Yeah, it's okay. Oh, test test. Okay. Hopefully it's not going to die again. It's on low battery, so I'm going to make the talk quick. Another distinction to make between volatility is that online you're able to download 2.6 and 3.0. 2.6 was the widely used version of volatility, the volatility framework, before Python 3.0. And right now, 3.0 is the one being actively developed with Python 3 in mind. And the demonstration that I was going to do was based on 2.6, which unfortunately is being used by an unsupported end-of-life version of Python. So you might have some trouble getting that to run. 3.0 also is different from 2.6 in a way because 3.0 is more it's more focused on development and the framework sense, where 2.6 was more of a tool. Yeah, so the next slide are kind of some further references. I was going to do the demonstration on MemLabs Lab Zero. Unfortunately, we're not able to do the full demonstration, but I can kind of okay, I could probably try using the webcam mic, but okay. Um, Yeah, so I can go through kind of MemLab's Lab Zero, which will walk you through how to use Volatility 2.6. So we can kind of look there. And there's also Awesome Memory Forensics, which is a kind of directory on some more memory forensics. Oh, check, check. One, two. Okay. Um, yeah, I'll just have to make my talk brief again. So yeah, we can go through Lab Zero of MemLabs, which was what my demo was going to be about. And it's structured in a sort of CTF style. So basically, you're given a prompt and you're trying to find a flag that is essentially the answer to the challenge. So we can read the challenge description here. Let me go ahead and zoom in. Okay, hello. All right. So the challenge description is my friend John is an environmental activist and humanitarian. He hated the ideology of Thanos from the Avengers Infinity War. Testing one, two, three. Okay, cool. So, all right, we'll just have to use that for now. Okay. So he used memory variables while running the program. One day, John gave me a memory dump and asked me to find out what he was doing while he took the dump. Can you figure it out for me? And so the challenge file is a raw file. I can actually um, download it and show you guys what it looks like, just to show how you're going to need volatility to analyze it. Let me see if I can download it real quick. Okay, no, I just forget about it. That's okay. We'll go. We'll just go through the what I wanted to show you guys. So, like I mentioned earlier, volatility is a command line tool. So you will need to have some sort of knowledge with command line utility, and it's a cross-platform tool that you can. It is available on Windows, Mac, and Linux machines. For Windows, I know you can use PowerShell to use the utility, as well as on Linux or Mac, you can use the terminal. So the syntax here is pretty straightforward. You launch the volatility executable, and then you specify the file that you want to analyze with the -f and the challenge.raw file, which was the challenge file that is for this lab. So initially, you're not really sure when you're given a memory file what the image is about. What you can do is use the command image info, which gives some preliminary information about the image file. Um, so using some sophisticated algorithms, it is able to determine that the image is either it is Windows 7 based. There are three different versions. Standard pack 1, 86. So we know it's an 86 based machine. So what we also need to do in volatility is we need to specify the type of profile that the image is built on. And we can do that with this little demarker here. Dash profile Windows 7 SP1 -86. That's just one of the suggest profiles that was suggested in the image info command. And what's cool about volatility is um, it's has this huge amount of modules, like I mentioned earlier, or plugins, and that's essentially what this command does. Is a plugin to show the process list of the image file. So every image file comes with well, every memory dump comes with basically a whole snapshot of the data in RAM at the time it was taken. So we know that from that information, we can generate a list of the processes that were running on the system at that time. So it shows a list here, similar to if you use Task Manager on Windows and you use the Services tab. It is very similar to that. We can see some useful information here, such as the offset variable, which is the address at which the service is started at or is stored at in RAM. You can see the name of the process, the parent, the process ID, the parent process ID, which essentially is the ID of the process that created the process ID, because processes are created by other processes usually, and the parent process of all processes is the system process. We can see the number of threads and handles that it uses. We can see the session ID that it started. And we can also see the start and the start time of the process, which includes the date. So long story short, we can use the PS list to kind of shorten down some processes that might be of interest in this CTF, in this challenge. Command.exe is one of them, which is the command line executable. Essentially, when you use command line on a Windows machine, it'll spawn the cmd.exe process, and so that's something we might want to check out later. We can also notice dumpit.exe, which is the dumpit file, the dumpit program that was used to create the memory image, like I mentioned earlier in the presentation, and also explorer.exe, which is file explorer. So one of the other plugins that we can use is CMD scan, which scans for all the commands that were inputted through command line um, in the memory image. And so when we type that in, we can notice that command 0, which was the first command that was executed through command line, was referring to is executing Python on a text file. So, and it's named daemon.py.txt. So that's something that may be of useful information. We can also go through the command called consoles, which gives us a more accurate look on what the user was looking at on the command line. And we can see that it outputted to them this kind of string here. And this string is hex encoded, so we can decode that and get this weird gibberish string. Other than that, we're kind of stopped there. But after that, we can go back to the description of the challenge and note that the word environmental is in quotation marks. And so in programming, environmental usually means something along the lines of environment variables. And so what environmental variables are basically a set of variables that are executed or set before any other command is run. And that command will take in those environmental variables that are already set. So we can print a list of all the environmental variables that were stored, that were set on this computer at the time of imaging. And we can see a variable called Thanos with the value of Zor and password. So that's also something that we can take note of. So we can take that down, decode it in a hex, but also run it through a Zor decryption. And you will get this text, this part of text that is recognizable. It just says, "I am better" in leet speak. Okay. So we have two pieces of information now. We can go back to the environmental variables hint, and the other half of the hint here is password. And so what we're also able to do with volatility is pull the hash map or the hash values of user accounts at that time of the dump. And what we can see here is when we use the hash dump plugin with volatility, we're able to pull the hashes for 3 different accounts: the administrator, guest, and the account hello on the computer. And let me break this down really quick. The first field here is just a user ID for the accounts on the computer. The second kind of field is a standard kind of hash variable for, it's not really that important for Windows, but this is a Windows 7 machine, so it's basically centered on this across all computers. The third field is the NTLM hash, which was an outdated hash that Windows 7 and up to 8 used to hash the passwords and store them securely. So we can actually use an online hash hashing tool. Hashes.com is one. And we put that hash in the website and it's able to crack it because it's so outdated and it's unsecure. That's why version after Windows 8, when Microsoft replaced the hashing algorithm from NCLM. And we get the part of the flag called "You are good," but um, it is incomplete. So we put those two flags together, and we have that little bit of information that we gathered from a memory dump. So off the top of my head, there are also some more valuable volatility plugins that you can use. You can dump the application data. You can dump actual executables from the memory image, as well as extract some other files from the file system that were stored in RAM. And that, I'd say, is what you can do with volatility. Well, that's all that we covered in MemLabs. There are several more labs that you can do on your own at home, 6 different labs. And I'd say it's a very useful resource in regards to memory forensics when you're going to do something hands-on to build up your knowledge of memory forensics and volatility.
Show us for the other link that you had for your reference.
Oh yeah, sure. So there's a list here called Awesome Memory Forensics. It's basically a open source list of all different resources about memory forensics. Here's some of the tools that you can use. These are acquisition software. You can see Magnet RAM Capture is one of them. FTK Imagery was one of them. Acquisition is for iOS, macOS machines. There are some hardware tools. And for memory analysis, there are, like I mentioned earlier, a bunch of different tools. But Volatility 3 is the kind of one that you want to be using for memory forensics and FS as well. Here's some books. I really recommend this one, The Art of Memory Forensics. It's I'd say the latest piece of reading that you can read for memory forensics. Learning all about it. It's a good read. Here's some courses and videos. I will be posting these slides on the Discord later on after this meeting. So if you guys would like to check that out, you can feel free to do so. So yeah, that concludes my presentation on the introduction to memory forensics. I hope you guys enjoy that, and thank you for coming. If you guys have any more questions or comments, go ahead and feel free to ask them in the chat or raise your hand in class.
Yeah, the mic's not here. Okay, I'm just gonna wrap it up. Thank you guys so much for coming to today's meeting. Before we close it off, I do want to make a couple more announcements as mentioned in the beginning of the meeting. Once again, we have a workshop on web application security coming this Friday from 2 to 4. If you're interested in that, hopefully you can check that out either in person or on Zoom. This will be a collab with the CSS Club, which is a computer science club on campus, and they do a lot of really cool stuff. So hopefully I can see you there. Other than that, I believe there's with some other events that you could check out on the Discord announcements. I believe next Friday there is also going to be a cool social event regarding I think it's related to like Squid Games. So if you're interested in hanging out and doing some fun activities with that, more information about will be posted next week as well. And I think that's pretty much all from me. So I mean, I think we're pretty much done here. So thank you guys for showing up. And hopefully I'll see you this Friday.
All right, sweet.
Thanks, everyone.